Okay, so let's talk about the discriminant a little bit more. And remember, the discriminant is the stuff that's under the square root in the quadratic formula, b squared minus 4ac. And in an earlier video, we talked about if the discriminant, b squared minus 4ac, is positive, you have two real solutions. If it is equal to 0, you have one real solution. And if it's less than 0, you have two complex solutions. Now, two complex solutions means here two non-real complex solutions. So there we go. Now, one of the things that you may be asked to do to play around with the discriminant is you may be given the value of a discriminant of a quadratic equation and just asked about the number and types of roots. That's pretty straightforward. So then if I say the discriminant is like 64, you know that 64 is bigger than 0, and so there are two real solutions. Another way, however, that you may be asked to use the discriminant is like this. If I give you, say, a quadratic equation, let's say 2x squared plus 5x plus some number m equaling 0. And then I tell you that this quadratic equation has no real solutions. And then I ask for the possible values of m. The way we look at this is the problem tells me we have no real solutions. And so when there's no real solutions, we know the discriminant, the b squared minus 4ac, is less than 0. So I'm going to build the discriminant for this quadratic equation, b squared minus 4 times a times c, which in this case is the letter m. And in order for there to be no reals, then this is going to have to be less than 0. So then I'm going to simplify my stuff here and then solve the inequality. Dividing both sides by -8, which of course flips the direction of the inequality. And so this is a description of all the values of m where we would have no real solution here. I'll give you another one just so you can make sure you understand it. So I'm going to give you another quadratic equation. Let's make it q this time instead of m. And this time, let's say there's one real root. And then what are the possible values of q? So again, we look at how many roots we have, one real, and when it's one real, the discriminant equals 0. So I'm going to build the discriminant, b squared minus 4 times a times c, which in this case is q. And if it's one real root, that's going to equal 0. So then I solve the inequality that I've got, which in this case is an equation. And in this case, q would only have one possible value, 4/3. Now, if it was positive to like two real roots, then that would be the discriminant greater than 0, but the process would be exactly the same.